Hey, here's the next video. I'm looking now at questions 20 and 21, but I guess I'll start with 20. And it says, let f be the function given by f of x equal to e to the negative x, very famous function, and let g be the function given by g of x equal to kx. K is a non-zero constant, that's important, so I'm going to underline that, such that the graph of f is tangent to the graph of g. Find the x-coordinate of the point of tangency and the value of k. So the most important piece of information here is that the graph of f is tangent to the graph of g. So here's a picture of what the question's saying. We have two functions, f. I'm not sure that this is what f looks like, but I'm just making that up, and g. And again, the graph of f is tangent to the graph of g. So they touch each other, but they barely touch each other at just that one point. And so they are tangent. They are not just intersecting, they are intersecting each other in a very peculiar way. They are tangent. And hopefully you can see the difference between just intersecting. Because for instance, if you follow the laser here, this could have been G here like this, but this is not tangent to F. This is intersecting F. But the way I drew it, that's intersecting F, but in a tangent fashion. So F and G are tangent, and so a couple of things happen when F is tangent to G. First of all, if F is tangent to G, then G is tangent to F. And at the point of tangency, one thing that must be true is that f has to be equal to g. Why is this? Because it's a point of intersection. Not just a point of tangency, but a point of intersection. F and g are equal at this particular point. Another thing that's true is that if you were to draw a tangent line at that point where they intersect, then the line tangent to f is the same line as the line tangent to G, and if it's the same line, then the slope of the line tangent to F is the same as the slope of the line tangent to G, because it's the same line. So then we can come up with equation 2 here. F prime has to equal to G prime. And so we now have two equations that will help us figure out this problem. Please go back, take your time, pause the video if you need to, make sure you understand this. This is a statement that was not said in class, but aren't you glad you're watching the video now? If f and g are tangent to each other, then f has to be equal to g because they intersect, and since they have the same tangent line, there's no way you could draw any other tangent line there, then f prime has to be equal to g prime. And so what we're going to do now is use these two equations and come up with something we can solve. I'm going to start with equation 1 and say that f is equal to g. So from equation 1, f is equal to g. That means that e to the negative x has to equal g, which is kx. And that's a good equation. Now looking at this equation, there's nothing I can do with it because I have two variables, x and k, and I'm not going to be able to do anything with x or k. So I guess that's the end of that equation. My second equation is that f prime is equal to g prime. So then let's go ahead and find f prime of x and g prime of x. F prime, f is e to the negative x, so f prime is e to the negative x times the derivative of negative x, which is negative 1. And I can just make it a coefficient at the front, negative e, negative x. Now g prime of x, g prime of x. G of x is k times x. I'm not going to do a product rule because k is just a constant. It's like saying 7x, negative 2x, 3/4 x. So then the derivative of that is just k. And so we have our second equation. Our second equation is negative e technology, negative e negative x equals k. And again, I'm stuck with that equation because I don't know x or k. But now that I have two equations, in my Algebra 2 class they told me that's called a system of equations, and you can solve it by substitution. So I'm going to go back to my top equation, and since this one's solved for k, I'm just going to take this k value and plug it in right there. So then we have from equation 1, e to the negative x equals k times x, but k is the same as negative e to the negative x. And now I can solve for x, because look at it. All my variables, my only variable is x. What do you propose we do to solve for x? I propose we divide by negative e to the negative x. And so if I do that, we'll get x equals, well, these two are the same, so I should get 1, but then this one's negative. X equals negative 1. Ta-da! And you know, sometimes you get so into the question that you forget, you get too into the problem that you forget what the question was. The question says, find the x-coordinate of the point of tangency and the value of k. I guess we found the x-coordinate. The x-coordinate is negative 1, but now they want us to find the value of k. Well, if x is negative 1, you can go to either one of the top two equations. I'm going to stick to this one here, and I'm going to let x be negative 1. So I'll have negative e to the negative 1 equals k. And that's just negative e to the positive 1 equals k. But negative e to the 1 is just negative e. So we found x and we found k. What I want you to keep in mind is this statement, very powerful statement. If f and g are tangent to each other, then f has to be equal to g. That just means they intersect each other. And f prime has to equal to g prime. They have the same tangent line. Okay? Maybe I should write that down. F equal to g means they intersect. And f prime equal to g prime, they have the same tangent line. You can see it from the picture, hopefully. This one's a short video. Check your email.